All right. So we'll get started here on 7E. Let me try to blow this screen up a little bit if I can. Um, our discussion questions are going to look kind of like this. So let's get started here, and I'm going to tell if I can everybody see. Yeah, we should be good. All right. So we're starting with arc AC. All right, the arc AC, which is sort of right down there. Okay, and the length of it is 7.85 inches. All right, 7.85 inches is the length of that arc. Okay, and the central angle for arc AC is 5 pi over 18 radians. Okay, which means that this angle from A to Y to C, that angle is 5 pi over 18 radians. Okay, so first thing this thing is going to sort of ask us to find is the radius, and that's going to take us back to our 7D notes. Okay, so our 7D notes said what formula? What was equal to what times what? If we have our 7D notes, okay, we had an arc length formula on there. Okay, so the length of the arc is equal to theta times r. Okay, so the length of the arc is theta, which is how many radians the angle is, times the radius. Okay, so um, so if length is equal to theta times r, all right, we know to get r, we'll just do what to both sides. If we have to get r by itself, okay, we'll divide by theta. Okay, all right, so r is equal to length divided by theta right there, and so that's what we'll do first. So for the radius, it'll be 7.85 divided by parentheses 5 pi over 18, and again, make sure we put parentheses um, in that thing right there. Okay. So the length of the arc, 7.85 divided by 5 pi over 18, which is our radians, is going to give us what the radius is equal to. And if we go to our calculator, 7.85. Let's type that in here. 7.85 divided by parentheses 5 pi over 18. And in the Google calculator, you just hit the P button that gives you your pi. You know what I mean? So it's you don't even need to find the pi button on there. You just type that in, and so it gives us a radius of about 9, 8.995. So we'll just round that up to 9. All right. My pen. All right. All right. Any questions so far, guys? Okay. Let me try to get. Maybe I'll get out of y'all's way a little bit. Can you see Janai if I'm right here? Okay. All right. So that's that. Now we're gonna try to find AD, YD, and DC, and that's really kind of the most of what we're gonna do here. Um, Anybody who saw the video from the other day, how are we gonna go about doing this stuff? Do y'all remember? Anybody who maybe got ahead a little bit? No clue. No, nobody remembers. Guess not. Can I clear the screen? Is everybody good? Everybody good? Okay. So we know the radius is 9, and what I'm going to do is I'm going to try to come over here. And so we have this little triangle right here, right? And hopefully you saw in the original video, is we're going to sort of go back to doing sort of our trigonometry type stuff. All right. So here, it's a little too much. Stupid thing. Okay. So I have a radius of 9. Okay, in this little right triangle right there. And let me blow this up. So in this little triangle right here, I have a radius of 9, and we know where the angle up here is 5 pi over 18 radians. All right, and it's a right triangle. I have a perpendicular 90-degree angle right there. Okay, all I'm doing, I just took this little triangle here and I transferred it over there. All right, so to find AD, which is this bottom side right there, does anybody remember which function that we would use on a right triangle to find the length of AD? Yeah. Which of our functions, trig functions, could we use to find AD? Annie? But we only know one side right now. We know the radius, the hypotenuse, which is 9, which is the hypotenuse. AD is the opposite leg because it's opposite the angle that we know. So we have, we're working with O and H right there. Does anybody remember? Unit 6, 6A notes. Sine, cosine, or tangent. Which one? Sine. Sine. Because sine is O over H. Okay? So in order to find that thing, I drew on the wrong triangle. Sorry. So the radius is 9. We have our triangle right there here. So radius is 9. This is the hypotenuse. I'll come down to this triangle here. It's drawn up a little better. So the radius is 9, and and that's the hypotenuse. We're trying to find the opposite leg. Okay, so we're gonna use sine. So to find AD, which is what we're looking for, we're gonna use sine. So the sine of our angle, which is 5 pi over 18, equals x over 9. All right. So the sine of our angle, 5 pi over 18, equals x over 9. And so to get the x by itself, we're going to do what? Multiply by 9, okay? So this bottom side AD right there is just going to be 9 times sine 5 pi over 18. All right, and that's what AD is going to equal, okay? When we put this in our calculator, what do we got to make sure our calculator is in? Really? Degree mode. Because this angle was 5 pi over 18 what? Sorry? It was radians, so what mode should it be in? Radian mode or degree mode? Radian mode, okay? So because our angle, remember our angle is measured in radians, any sine, cosine, tangent, any trig function we got to do in radian mode, okay? If we wanted to take the 5 pi over 18 and convert it to degrees, then we can go to degree mode, but you know what? It's already in radians. The arc length formula is easier in radians. You know what I mean? Let's not make life harder on ourselves. Let's just do the darn thing in radian mode. I'm sorry? Mm-hmm. So our hypotenuse is 9, and we're timesing that by sine of 5 pi over 18. Yes. Good. And so that'll give us our AD right there, about 6.9. All right. So going back to our trig rules, we use that central angle and the radius also being the hypotenuse of the right triangle to get that missing side right there. Okay. So as I come back to clear my screen, so your radius of 9, AD is about 6.9. which means dB is also 6.9. All right, so now we have to find YD. Now in the triangle right there, 9 was this, 6.9 was this. This is the hypotenuse. This is the opposite. Which leg is this thing called? Do y'all remember? The adjacent's the A. Okay. And we have the A. We could use O and A, but I'd rather use the number that they gave us, 9. So if we're going to do A and H to find that YD, which function would that be? Would it be sine, cosine, or tangent? Cosine. Remember, tangent's O over A. Okay. So when we did AD, just to recap, we did 9, sine of 5 pi over 18. Okay. For YD is going to be the same thing, but instead of sine, we're going to use cosine because we're going A over H now. So for YD, it'll just be 9 cosine of 5 pi over 18. All right. So 9 cosine 5 pi over 18. Again, the angle's in radian mode, or the angle's in radians, so we'll just keep the calculator in radian mode. And no one's the wiser. So, now we have, coming back to our calculator, all right, we have 9 cosine 5 pi over 18. And that'll get us our adjacent leg, which is going to be about 5.8. Whoops. Am I going too fast for you? I thought you said too fast. I know I'm not talking about how I run, I'll tell you that. All right. So in this little triangle right here, again, I'm going to blow it up a little bit. So that triangle, now we have radius of 9. This thing is 5.8. This thing is 6.9. The last thing it's asking us to find is DC. All right. How are we going to find DC, which is this little piece right down there? We could. But okay, so we know what YD is 5.8. And I think maybe, do we know what YC is? It's 9. Why, Preston? Yeah, it's the radius, right? So this radius from Y to A is 9. Well, this radius from Y to C is 9. So all we got to do to find DC, now that we know this, is do what? Subtract. What with what? Yeah, just 9 minus 5.8. Yeah, it is. It's just, we have to go back to stuff that we learned kind of a while ago, And so that DC thing right there, 3.2. Good. Get this out of y'all's way. So I think, the discussion question that I put up is very similar to this problem right here. I could do another one if you want me to, or you guys can try to piecemeal it together. What do we think? Piecemeal it together? Okay. I'm gonna stay here. I'm gonna record one more just in case. So I'll put the video up. So if you're not sure, you can kind of watch while I record. for the next one. If you feel that you can go ahead and do the discussion question, you can go ahead and do that. Is everybody done writing, copying down? Is everybody cool? Alexander, Nathan, are you good? You good? Okay. Jania's good. Wesley, Ethan, Alexander, everybody's good. Dylan, Annie, we good? Okay. All right. So looking at this next one here, the length of the arc AB is 34.19. Okay. Now this says the central angle for arc AC. So the central angle for arc AC, which would be this angle right here, is 7 pi over 9. Okay. But let's be careful because that's really not, the 7 pi over 9 doesn't go with the 34.19. Okay. The 7 pi over 9 goes with AC. So what I think the easiest thing to do is we'll divide the 34.19 by 2. Okay. So if we do the 34.19 divided by 2, we get 17.095. Okay. So arc AC is 17.095. Okay. And the central angle that goes with it is 7 pi over 9. So again, we'll do what we did earlier to find the radius. We'll do arc length, which is 17.095. And we'll divide it by, parentheses 7 pi over 9. Okay. 17.095 divided by 7 pi over 9. So, again, make sure that fraction in the parentheses. And so we get a radius of 7, 6.99, so about 7. Okay. The thing's going to ask us for AB. Okay. Now, what we know about AB is really double of AD. So what we'll do is we'll find AD using this little right triangle, and then we'll just double it. Okay. Because this is sort of our rule. So again, for AD, we know that AD with a radius being 7. Okay. AD is the opposite leg. 7 is the hypotenuse. Okay. So we know AD is going to be, 7 sine of 7 pi over 9. Okay. So AD is going to be 7 times 7 pi over 9. Okay, so AD is going to be about 4.5. I'm doing a video here, me. I'll be with you in a minute. All right. So AD is going to be about 4.5, making AB 9. All right. So coming into our triangle, which I'm going to draw right down here, my radius is 7. This thing is 4.5, and again, my angle is 7 pi over 9. Okay. We got to find DC, okay, which is this bottom little piece right here. And we know that DC is really going to be the radius, which is 7. And we got to subtract YD. Okay. Now YD, which is that part of the radius we did on the earlier problem, is going to be 7 cosine of 7 pi over 9. So then we got 7 cosine of 7 pi over 9 in our calculator there. All right, it's going to be negative. It says negative 5.36. It's really going to be positive. So it's positive 5.4. It's a complicated thing about the cosine of an obtuse angle right there. So cosine of 7 pi over 9 is going to be positive 5.36. So we'll call it 5.4. Okay, and so DC, which is the other part, is going to be 7 minus the 5.4, which is going to be 1.6. Okay, so again, same deal there. If we're trying to find this AD thing, we'll use sine. If we're trying to find, YD, we'll use cosine. That's if we're given the radius. And that's what our discussion question is going to be over. If they give us other stuff like AD and YD or something like that, then we may have to go and do tangent, in order to find some other pieces, or we'll have to maybe do, you know, dividing sine or dividing cosine, sort of depending on what they give us. But we're just basically just applying our trig rules here with right triangles. So I would encourage you to go back and look at your 6A notes on how to do trig with all this stuff, and that's really what we got. So best of luck on the warm up assignment, and y'all have a good weekend. Take care.